Calculating the pH of strong acids and bases is easy because they dissociate completely. But weak acids and bases dissociate only a very small amount in a reversible reaction. The equilibrium equation for the dissociation of a weak acid has the weak acid and water as the reactants, and the conjugate base and H3O+ as the products. The equilibrium expression is products over reactants, so Ka, where A stands for acid, equals the concentrations of the conjugate base times hydronium over the weak acid. Remember that liquids don't affect concentration, so we should omit water from the equilibrium expression. The value of Ka will be small because there's very little dissociation in weak acids. The larger the K is, the more dissociation there is, which means the stronger the acid is. Given the values for Ka, which acid is the weakest and which is the strongest? The weakest acid should be the one with the smallest value for K, because that's the acid that dissociates the least. The strongest acid would be the one with the biggest K, because that's the acid that dissociates the most. To calculate the Ka of a weak acid given its pH, we use the following steps. First, write out the equation for the dissociation of a weak acid. Then set up an icebox with the initial concentration of the acid and zeros for the products. And don't forget to cross out water because liquids don't affect concentration. Calculate the equilibrium concentration of hydronium ions using the equation H3O+ equals 10 to the minus pH. Determine the change values according to the stoichiometry of the equation. The change of the acid will be negligible because weak acids dissociate such a small amount, so don't even bother subtracting it. Then use the equilibrium concentrations to solve for K. To calculate the pH of a weak acid given its Ka, we use the following steps. Write the equation for the dissociation of the weak acid. Set up an icebox with the initial concentration of the acid, zeros for the products, and liquid water crossed out. Use X in the change row and make sure to follow the stoichiometry of the reaction. And assume the change for the acid will be negligible, so don't bother subtracting it. Then solve for X using the given K value. X is the concentration of hydronium at equilibrium, so you can use the equation negative log of the H+ concentration to solve for pH. The equilibrium expression for the dissociation of a weak base has the weak base and water as the reactants, and the conjugate acid and OH- as the products. The equilibrium expression is Kb, where B stands for base, equals the concentrations of the conjugate acid times hydroxide over the base. And remember to omit water because liquids don't affect concentration. Note that if the products include H3O+, then the reactant was an acid, so you'll use Ka. And if the products include OH-, the reactant was a base, so you'll use Kb. To calculate the pH of a weak base given its Kb, use the following steps. Write the equation for the dissociation of the weak base. Set up an icebox with the initial concentration of the base, zeros for the products, and liquid water crossed out. Use X in the change row and make sure to follow the stoichiometry of the reaction. Assume the change for the base is negligible because weak acids and bases don't dissociate very much, so don't even bother subtracting it. Then solve for X using the given K. X is the concentration of hydroxide ions, So use the equation POH equals negative log of hydroxide to solve for POH. Then subtract POH from 14 to solve for pH.